step, we will see how our OTM application works and how the application will look like. So this is a simple OTM application where I have initialized with one user because when you see the code, we have already provided we have already added just one user in the constructor. So do you remember this code? So here we have already added just single user, and in our deploy script we have passed this user one as the input. See, so we'll be having only one user as the thing. So this add candidate. So this is what the simple voting application will look like. So the add candidate will dynamically add the users on this table. That table will be dynamically be updated. So for suppose I'm giving one more user, say user 2, and click on add candidate, the table is dynamically uploaded. Similarly, I'm giving one more user and just click on add candidate, the table will be dynamically uploaded. So for each of this user, unique ID has been created for this rows, for these columns, for these columns. So whenever, suppose I want to give oath for user 2 and I click on the oath, then if I click one more time, so the oath will be dynamically uploaded. If I click one more time, see, the votes have been dynamically uploaded for this user 2. Similarly, if I'm going to provide the user 3 and click vote, the vote will be dynamically uploaded for the user 3. Similarly, for user 1 also, just for example. So this is how our OT application will work or will look like. So we have seen how to write the Solidity smart contract, and we have seen how to create the front-end applications and how to interact with the Solidity code. So just a quick recap of what we have done so far and what are the few more changes that I have done to the Solidity code. So this is one of my Solidity code. So here what happens is initially we have created a cast your vote contract, and we have created a candidate list, say user 1, user 2, user 3. So see, these users, the user 1, user 2, user 3 needs to be, it's like a array, right? So we have created an array. This very simple string array. I have not used any bytes or anything because just for the understanding I have created it. Then we did the mapping because for each person or for each candidate we need to count the number of votes we have listed. So we have created this one, and we have initialized our constructor, and we have created the what do you say, the function called add candidate, which will add the person. Like, see here, if I click on add candidate, the user 3 is added, right? So this user 3 needs to be updated or added to our candidate list. Then only we can count our vote. Then we have called the vote for. So here I have made one change. So initially, just for the reference or just as the to make you understand, to make the concept clear, I have created the for loop. But each and every time when we run the for loop, it will cost a transaction fee. So I don't want to run the for loop each and every time. So that's why I have created a function called is candidate exists, because if the candidate is exists, then we will count the votes, or else we will remove that one. I mean, we will throw the error. So that's what the is candidate received functions do it. It is not doing anything. It just compares the whether the candidate is there in the candidate list or not. If he is there, then it will return true, else it will return false. So it's a very simple require statement. Just replace the for with this require statement. Nothing else I have done. So for your if you want to try something, if you're not comfortable with this require statements, you can just comment these two lines and you can uncomment these lines. So just a dot, so to make clear. So okay, now we will just have a quick recap of what our front-end application, how our HTML page is, so we have seen the Solidity code. Let's quickly jump into our HTML page as well as our JavaScript page. So this is a very simple HTML page that we have set. It's a simple voting application, and we have created a table. Whereas, yeah, this is the table, and for each table, a unique ID has been provided. Because using this unique ID, we are going to dynamically add the rows to the table. So this is the header, table header, which contains the candidates and the hosts, and this is the table body, which was initialized with just one user. And for the next column where we are going to print the hosts, the ID is just provided. It is not going to have any values. It's just the ID. Now we have the two. If you see our application, so here we have one text box and one vote button. So that is what this one is doing. So it will, first one is the candidate to whom we have to vote, and then second one is the vote function. Similarly, we have one more text box where we can add the candidate. So that's what this new candidate text box, and this is the add candidate function. So similarly in the application.js, so as we know that in the candidate list is whatever we have entered on the front end. See, the basic thing is we need to make sure that whatever list we have here should be in sync with whatever list we have here. So that's a basic idea behind this one. So as we told, we have as the first step we have imported all the required libraries. Then once you compile your application, you will have the artifacts, the JSON artifacts will be stored in your build contracts folder. So you just need to import that and store it in some variable, and you have to get that contract and store that contract in the voting. So in the future steps, we are going to follow this voting, and we are going to implement the functions. So the first function we have implemented is onload. The onload function is like whenever you are loading your application, so we will provide Web3 to point to which provider you need to point our application to. So here I'm using the HTTP provider, and then for this voting we need to set the provider. So we need to tell the voting application to listen to this provider, and then this voting dot deployed. So this dot deployed is already the predefined function that is there in our Truffle contract. So because here you see we have created the voting which is using this contract function of this Truffle. We pass this as the argument to our Truffle contract, and we are getting the values. Okay. So once this is done, then okay, one more change I have done is the reset votes. The difference between the reset votes and the total votes. So these total votes will always be incremented. So whenever, even if I reload the page, it is not going to be reset. So that is how the functionality should be. It should not be reset, but just for the explanation, or just to make sure how it works, or just to make it understandable for each and every one. So that's why I call the function reset. But remember, the reset is just for the understanding purpose, because we don't want to reset each and every time our Solidity code or the smart contract whenever the page is loaded. That is not the idea behind the smart contract. But the basic idea I'm showing here, or the basic the reason why I have called this reset function is just to understand how the Solidity is performing. But never reset your code or your values in the smart contract, because smart contract is like a, then there is no use for going to the smart contract. And once you deploy the smart contract, you have to be something that is non-erasable, very steady code needs to be there. Yeah, just for the understanding, I have created this reset code, because what happens is, suppose here I have the Solidity code. Yeah, for the user one, I'm having the one. Now again, when I'm reloading this page, you know, Once if I am not passing this reset, and if I get cast a vote, it will show number. It will show 2 as the votes because this already is already having 1, right? So it will show 2. So that is the reason, just for the testing purpose, I did reset, or else I wouldn't have done that reset. Okay. Then, so this is the add function that we have already seen. So what needs to be done when we add the candidate to the listings? This is the add function. This is the send transaction. So whenever you call the send transaction, you need to pass the from which account and what is the gas. If the gas value is not passed, it will take by default values. If it is if the from address is not passed for the send transaction types, then it will throw you an error. So whenever you are calling the send transactions, you need to pass the from and the gas, or even not the gas, at least from. So whenever you are reading the transaction, you will call the function call. I mean, you will use the word keyword call or the object call. So this is because we are just returning something from the Solidity. Solidity or the smart contract is giving you some output. So that's why we are making the word call. But here you are going to add something to the smart contract. You are going to change the state of the smart contract. You are going to add some transactions over the smart contract. So that's why we are making this as a transaction type. It's not the call type, it's the transaction type. So whenever we make the transaction calls, we need to add the address from like who is making the transaction. Okay, so this is a simple code. Hope you understand this code very well, because this was written in a very simple manner to so that each and every user can understand the code. And even I'm not using the string bytes or any other data types. I just use the string, so it will be very easily understandable for everyone. So once this is done, so this is how the smart contract, and this is how our web application, so we can play with this. And I will add the GitHub link also in the comments. Thank you.